In this video, we will explain the basics of digital images. Digital image is formulated as a reflection of lights from any object. Here, the illumination source or light, the object, the reflected lights. Then the reflected lights will be pass an imaging system. Usually, it is an analog to digital converter. The analog digital converter performs three basic operations to convert the image from analog signal to digital signal: the sampling, quantization, and encoding. At the end, we get the image matrix or the digital image. Here, how the analog digital converter operates. This is the operation of the sampling, quantization, and encoding. Then we get two or three dimensional matrix depending on the image. If the image is binary or gray, then we have a 2D matrix. This 2D matrix will represent the digital image. If the image is color, then a 3D matrix is used to represent the image. The first dimension will represent the red color. The second dimension will represent the green one. And the third dimension will represent the blue color. The values of the pixel here, the pixel is the intersection of rows and columns. The image resolution will be measured by the rows and columns. Multiplication of rows and columns will give the image resolution in pixels. The size for the gray image, each pixel requires 1 byte, and the values are ranging from 0 to 255. 0 for the black color, 255 for the white color, and between them the color will be range from the dark to the white. For the color image, each pixel has also a value: red, green, blue. Also, the range is between 0 and 255. Mixing these colors will be generate the certain color. For example, if the red 255, green 0, and the blue 0, then the output color will be red. 0, 255, 0, the color will be green. 0, 0, 255, 255, the color will be blue. 255, 255, 255. All the colors have the value 255. Then the resulting color of the pixel will be white. 0, 0, 0, the color will be black, and so on. Also, we can deal with the binary image. Binary image also as the gray image. It's a two-dimensional matrix. The intersection of the rows and the row and column will give us a pixel with a value 0 or 1. 0 means black, 1 means white. Usually the digital image, color or gray image, has a huge value, huge size, kilobytes and megabytes. So we can represent the image by the histogram. The image histogram is a one-column array with 256 elements. The first element points to the repetition of 0. The second element, the repetition of 1. The last one, 256 element, will point to the repetition of the gray value, 255. Here an example of the image histogram. Here the repetition of the values. Suppose we have the monochrome image, this like this one. This mean 1 white, and this mean black 0. So the repetition of 1, we can calculate the repetition. 1, 2, 3, 4, it will be 12, and the repetition of the black color will be 4. Here another example. Here we have four values, four gray values. The white one with 4 repetition. This color repeated 2 times, and the black one repeated 4 times. This one gray, this gray color is repeated 6 times. For the color image, we can get the histogram for the red color, for the green, and for the blue. Totally, we can add these histograms together to get the total histogram of the color image. Color image are useful for many applications. We can see whether the image is white or clear or not clear or dark. For example, in this example, we see that the values in the image are grouped to the dark. So we can say that this image is dark image. Here, the gray values are concentrated here, close to the maximum gray value. So the image will be light. Here, the values are normally distributed, so we can say that this image is a good image, an image with good contrast. Here we can see that the gray values are concentrated here between 120 and 200. Here we can see that the image has a low contrast. Here also, this image called a saturated image. We can, depending on the histogram, the image histogram, we can see whether the image requires enhancement or not. The first method of image enhancement is called histogram equalization. Histogram equalization means normally distribute the gray values between the minimum and the maximum to get a good contrast image. The histogram here for histogram equalization do some enhancement, and it will increase the contrast of the image, gray or color. This operation can be implemented using color image equalization. We have to equalize the red color, the green color, and the blue color. Here, an example of how to calculate or how to draw the histogram. Here we have a gray image for 1, 3, 2, and so on. We have to get the repetition of each value. 0 is repeated 1 time. 1 is repeated 1, 2, 3, 4, 5, 6, 7 times, and so on. If we want to equalize this image, we have to apply some operations. First of all, we have to find the repetition of each value. Here we take the value 15 as a maximum gray value, and here the values of the pixel will be between 0 and 15. The repetition of here we can repetition of 0 was 15, 1, 0, and so on, 970, 10, 110, and so on. After that, after finding the repetition, we find the accumulative repetition. Accumulative repetition means that the repetition with the previous repetition. For 0, the accumulative will be 15. For 1, 0 plus 15, 15. Here is the results, 0, 15, 15, 15, and so on. Then we will divide the results of the accumulative sums by the image resolution. Here the image resolution was 360. Then after that, the result will be multiplied by the maximum gray value, which is 15. Then we get the enhanced or equalized pixel value. So 0, it will be 1, 1, it will remain 1, and so on. 11 will be 10, 12 will be 13, and so on. Here the histogram after equalization, here the histogram before equalization. So here we spread the gray values to cover different values between the minimum value 0 and the maximum value 15. In MATLAB, it is very simple to implement the histogram equalization and to plot the image histogram. Here an example of plotting the histogram of the gray image, put.tef, image read, put.tef, image show, title gray image. We retrieve the image size in 1 and 2 equal size A, and 1 will be the number of rows, and 2 will be the number of columns, Here we get the size n1 multiplied by n2. Here the image is gray, so the resolution will equal the size. Some information from the image: maximum element, minimum element, average of the pixels in the image. Here are the results of the after implementing this code, the image itself, the size, the resolution, maximum value, minimum value, average of the pixels. We can use the instruction who's in MATLAB to get information about all the variables stored in the memory. Here, one of the variables was the image itself, A, the size, 291 rows and 240 columns, the type of the data items in the image will be unsigned integer and ranges from 0 to 255. Or 1 byte for each pixel. Another example here, we can plot the histogram and the image in one picture. The same image, .f, reading the image, subplot 2 to 1. 2 to 1 means 2 by 2, square 1, to show the image A. Here the image A. Then we can plot the image histogram. Image histogram can be retrieved by the instruction image hist. This is the histogram of the image. As we see here, the image, the pixel values are grouped between 100 and 200, which means that this image is dark or low contrast image. Equalizing this image, the equalization can be done by using the hist equalize. This is a built-in function in MATLAB. B equal hist equalize A means equalize the image A and put the result in the image or the matrix B. Here the image after equalization, it becomes more bright, and the histogram here we can see that the pixels value are normally distributed, which means that this image has a good contrast comparing with the low contrast image or the original image. The red histogram, the red histogram for the gray for the color image, we can here color image. This is Aqaba city photo. We read the color image a6.jpg. Then we plot the image with the histogram. This is the histogram of the red color. Then the histogram of the green. Then the histogram of the red. Here, the original image, red histogram, green histogram, blue histogram. Or we can add the red and the green and the blue together to get the total histogram here. After addition, adding the three histograms together, we get the total histogram of the color image. Equalizing also, we can equalize each color separately. First, we have to equalize the red one, the red color, then the green color, then the blue color. After equalizing, we gather these three colors into one image to get the total image, total equalized color image. Also, sometime, as we said, the values of the RGB color image for each color, the values are the range of the values is between 0 and 255. Sometimes we need to deal with other values. We can convert the image, RGB color image, to YIQ image by applying this formula. Again, we can also get the RGB image by applying formula 2. The YIQ image will have the values between -1 and 1. Here a program of how to do this. We get the image, read the image, then we convert it to NTSC, RGB to NTSCS. This is a built-in function. Then again, from an YIQ image to RGB, applying the function NTSC to RGB image. This material will be uploaded on the research page, and the link will be available with the video itself. Thank you, and hope to see you again.